So this one says convert the rectangular equations to polar form. This is actually very easy for us to do. First thing we should think of is what are our polar equations. So here they are. So in essence, for x, I'm just going to plug in r cos theta. For y, I'm just going to plug in r sine theta. So that's just going to be r cos theta squared minus r sine theta squared equals 16. Now what I'm going to do is I'm going to square them and simplify them as much as I can. Done with the equations now, so this is just going to end up being r squared cosine squared theta minus r squared sine squared theta equals 16. So then what I'll do is I can factor in r squared out here, which I want to, because in general, the way we try to work these formulas out is we try to get r equals some function of theta. So this would be an r squared then. And in here we get a cosine squared theta minus sine squared theta equals 16. And if we know our identities, we know cosine squared theta minus sine squared theta is actually equal to cosine 2 theta. So what we really have here is we have r squared cosine 2 theta equals 16. And that's honestly the best we can do for this equation. So that's our answer right here. Okay, now for the next one. Again, we need to know what the equations are for the polar equations. There we go. And essentially all we're going to do here is just sub in. So for my y is r sine theta. So I'm going to have r sine theta squared equals 4 times r cosine theta, because x is equal to r cos theta. Okay, so I'm going to square this on the left side here. So that's going to be r squared sine squared theta equals 4r cos theta. So again, I'm going to try to get these r's equal to on one of the sides and equaling some function of theta if possible. Like for the last one, we couldn't because we ended up with an r squared. But we'll play around with this one and see what we can come up with. So I'm going to subtract 4r cos theta from both sides. Okay, so then I'm going to get r squared sine squared theta over here. And it's going to be minus 4r cosine theta equals 0. So then I'm going to pull an r out. Oops, that's going to be r sine squared theta minus 4 cosine theta equals 0. So now essentially I just kind of look at two cases here. Either r equals 0, which is just identically 0. So in most cases we don't bother with that. And the other equation is going to be r sine squared theta minus 4 cos theta equals 0. And then I would move the cosine over and divide by sine squared theta. And I would get r equals 4 cosine theta over sine squared theta. And I could break this down a little more, not much more. I could call this 4 over here, and then I can call this 1 over sine of theta times cosine of theta over sine of theta. Now the reason for this, and I don't know if this is any better than what I've had already, but this would give me, and I'm just going to write this over to the left because I ran out of room here. This would give me R equals 4 secant theta cotangent theta. And that might be the answer that the book is looking for. Oops, I did a boo-boo. It's not secant theta. It's cosecant theta. And cotangent theta. Okay, that's correct. So that would be my answer. Apologize for that. 1 over sine of theta is cosecant theta. So that would be the answer for the other one. So there's my two answers.